Hello students, today we are going to study tension test in mild steel. Now the stress strain curve for mild steel. Generally, mild steel rods are highly preferred for many construction purposes as it has high tensile strength when used with concrete. Knowing the behavior of mild steel rod under loading helps in choosing for better use. This behavior of a mild steel rod under loading can be analyzed using stress strain curve for mild steel rod. Now the stress strain curve for mild steel consists of strain along the x-axis and stress along the y-axis. Stress strain curve for mild steel consists of various stages such as proportional limit, elastic limit, upper yield point, lower yield point, ultimate stress, and the last one is breaking point. Now this is the stress strain curve for mild steel. These are the points, that is A point, B point, C, D, E and F. Now we will see one by one each and every point in detail. If the stress is applied gradually to a mild steel rod, the strain also gradually increased, that is represented in point A, that is shown here. In this stage, when stress is removed from the rod, the strain returns to 0. It means that when the stress is removed, then the strain reaches to 0 value again. Thus, the 0 to A point is called as proportional limit. In this limit, the stress is directly proportional to strain, that is sigma is directly proportional to strain E. That means that the steel rod obeys Hooke's law. In this stage, the proportionality is expressed as capital E. Thus, sigma will be equals to capital E into strain. So, E will be equals to sigma upon strain. Here, E is the Young's modulus or modulus of elasticity. Thus, Young's modulus is defined as the ratio of stress to a strain of the mild steel rod. The unit of Young's modulus is Newton per mm square. The increase of stress to the point B, that is shown here, the strain also increased proportionally. It is called as elastic limit. In this stage, if the applied stress is removed, the strain returns to an original position, that is rod gains to the original shape. The stress increased beyond the elastic limit, the material undergoes deformation, which means that the permanent extension occurs and the mild steel rod does not regain its original shape even after the stress is removed. This is expressed as C to D point in the graph, which is called as yield point, that is shown here. In point C, at which maximum stress is required for a rod to undergo deformation, is called as upper yield point, which is shown here, that is the upper yield point. In point D, of which minimum stress is required for a rod to undergo deformation, is called as lower yield point, which is shown here. The increase of stress beyond this limit increases strain gradually to a point. This point is E, which is called as ultimate stress or ultimate strength point, which is shown here. Ultimate stress is the maximum stress the rod can withstand. Thus, this portion is called a strain hardening, which is shown here. Further increase of stress beyond the ultimate stress, the localized reduction occurs in the cross-sectional area of the rod, which is the weakest point of the material. This is called as necking stage, that means a breaking point stage. At this stage, the mild steel rod breaks, thus the curve drops to the point F. Resultant curve obtained is the stress strain curve for mild steel rod, that is the breaking point, which is shown here. Under the action of load, the point A to B is elastic region, which is shown here, and point B to F is the plastic region of mild steel rod, which is shown here. Similarly, if you plot the stress strain curve for any material, you can determine the yield strength, ultimate strength and the breaking point of the material. That is all about the tension test in mild steel. Thank you very much, students.